Am I audible?
Yes, Yami.
Thank you. Very good evening to all of you. Hope you are doing well and safe in this present situation in our country. I'm Yanakadim Sara, who is talking to you today. Today, we are here to join with our brand new session, which was organized by IEEE student branch of University of Vocational Technology, Ratmalana. To mark the beginning of this session, I would like to invite President of IEEE student branch of University of Vocational Technology, Ratmalana, Mr. Heshan Jaisingh, to deliver the welcome speech. Heshan, over to you.
Thank you, Yamika. Good evening, everyone. I'm very happy to welcome you all to today's session. Today's session also one of the technology-related webinar session organized by IEEE student branch of University of Vocational Technology. In our student branch side, we have organized many such kind of events, and also we hope organize similar session and competition in future as well. So I request to you to stay tuned with us for our future events. In today's session, we are mainly targeted to give a knowledge about cloud computing and AWS. So I hope you all can learn many more things related to this topic today's session. First of all, I would like to warmly welcome our valuable guest speaker, lead platform engineer and technical trainer, community lead DevOps Sri Lanka, Red Hat architecture and certified trainer, Mr. Heshan Dharmasena. Then our student branch counselor and senior treasurer, Dean of Faculty of Engineering, Dr. Ravindra Kogalage, and all other invitees. Finally, I would like to welcome you all. So I'm not going to take more time. I think now we can move on to our session. Thank you. Thank you.
Thank you very much, Mr. Heshan. Today's session is about cloud computing and AWS. I would like to talk about our keynote speaker. He is working as a lead platform engineering and technical trainer, community lead DevOps Sri Lanka, and also working for the Red Hat architect and certified trainer of the Red Hat. To conduct the session from here, I respectfully invite Mr. Heshan Dharmasena.
Hello, sir.
Hello, sir.
Hello everyone. Hope I'm audible.
Yes, sir.
Hello everyone. Can you guys hear me?
Yes, sir, we can hear you.
Hello, sir. We can hear you, but we can't see you.
All right. Do you guys hear me? Am I audible right now?
Yes, sir.
Yeah. Okay. Thanks. Okay. Let me share my screen. Okay. Right. All right. My name is Heshan, and I'm doing today's session with you guys. And I do have 9 years of experience in the industry with as an application support engineer, systems engineering, DevOps, cloud, and platform engineering. And I'm a BSA computer systems and networking graduated, as well as Red Hat certified architect, instructor, and an academy trainer as well. And I have followed a couple of certifications as well, and elected for a AWS Community Builder program for 2022, as well as I'm a DevOps Sri Lanka community lead. So here I am, and let's see how we can start with cloud computing. So the main focus of this session is give you guys some idea about what is exactly cloud computing. And you can see my agenda there. In the agenda, you can see the couple of topics has been colored in white color as well as the yellow color. So I try to focus more into the concepts of cloud computing, then few of the topics from AWS as well. The reason why I picked AWS here, just to give you some idea how the concepts of cloud computing are going to map with the AWS. I'm not going to promote AWS, but to just give some idea, I have to pick up any of the cloud service provider with such kind of examples. So in this case, I have already picked AWS for that, right? That's the main reason why we are going with AWS. There's no such any other preferences to go with AWS, just to like give you some idea how these concepts are mapping with AWS, right? So mainly, what is cloud? Right. So what is cloud? So you guys know what is cloud. Cloud is a remote location where you have a lot of components and utilities that will be shared through internet. So that is the main term of the clouds, and you can find a different number of different what do you call the terms and explanation when you are searching through the internet. So those are the resources, computers available in the internet, and we are connecting those through remotely through internet. That can be mobile devices, maybe the storage devices that we are accessing, maybe the network devices, whatever the components or services we are accessing through the cloud, right? So then what is cloud computing? Cloud computing, you can see the definition, which is displayed in the screen. This definition has been taken from the IBM site. So cloud computing is on-demand access via internet to cloud resources, application servers, data storage, development tools, network capabilities. There are many more, right? So hosted in remote data center managed by cloud service providers. That means there are a lot of cloud providers available, and those cloud providers, the organization, they are providing different kind of services through internet. So the services are like application, servers, data storage, development tools, network capabilities, and many other hosted services as well. We call those as a managed services. Right. So that is the difference between the cloud and the cloud computing. So I guess now we have like some kind of idea about what cloud computing is. So let's move to the next one, the concepts of the cloud. Right. So I have taken this as a good example, right, to give you some idea. I have done this to another couple of sessions as well. So just think about what we had before, like in 80s. If you need power to your home, you have to build like in the top screen, you can see a machine. So everyone should have to purchase that machine and do the maintenance. That's how you can get power to your home or your industry or your organizations. But then you can see, right, how you're going to implement that. You can't implement that. You have to buy it. There is a time frame. You have to wait. You have to order that. Then you have to send the purchase order. Then you can buy it. Once you bought it, you have to do the maintenance. And if something goes wrong, you need to like call for the particular engineers to come and fix that. Likewise, you need to have like particular knowledge to manage that. And whenever you need some more if there are any what you call enhancement needed, then you have to call for that relevant parties of the engineers and come and fix that or add the components. And you cannot ignore it if you don't want. You have to wait for you already purchase it, so you already spent money on that. So likewise, you have to depending on what you have already bought. That's how in earlier days we use power. But what happened is nowadays the people has now people think more beyond, and what they did was now they create a central power stations, and now they distribute the power among the grids. Now in this case, what happened is you can see it's very easy. It's very easy to connect because power is everywhere. You just need to send the order. Yeah, I need power. Then they will implement. So power is with you. Then no maintenance. You are not worrying about the maintenance. It's totally up to the service provider. So they are managing that power. If the breakout, any breaks happen, they will come and fix that everything. And it's pay as you go. You only need to pay what you are going to use only. So you are not paying for any other things. And next will be so whenever you need, you can use it. Whenever you don't, you can clearly disconnect it. So now you can see how easy is this process, right? All right. So that's how the power grid connections and now what is the current situation looks like. So this is the similar concept we can apply for the cloud as well. So in earlier days, we use our mainframe computers. We use servers inside our organization. We had to manage the servers with our organization. Then we need to manage the server room, backup power, backup internet, cooling systems, maintenance. If something goes wrong, we need our engineers to go and fix inside the server rooms and wiring, cabling, and everything. But nowadays, we are not managing our server rooms. We are not managing the servers. No server rooms, no power, no backup power, no AC, nothing. We are just using the remote resources in some other data center via remotely. And we are not spending money on creating the servers, spending hard disk, spending RAM, CPU, and nothing. No, we just use someone else's machine, someone else's data center machines remotely for our case. So when we need machines, we buy the machines from them, and when we don't want, we just ignore it. We just delete the machine. So then we don't want to pay. So in this case, we pay only for what we are going to use only. So you can see that same scenario. The power grid scenario can be applied same into our cloud computing as well. All right. So okay, just give me 2 more minutes. There's a power cut in my area. Just give me 2 more minutes. All right. Can you guys see my screen?
Yes, sir.
Right. Okay. Right. Cool. Sorry for the inconvenience. I just had the power outage in my area, so I had to get. All right. So So we cloud concept. Right. So yeah. So in cloud concept, as I mentioned, in earlier days in 1950s, if you want to have the electricity, you have to buy one of that large kind of machines, and as I mentioned, you need to purchase it, install it, and maintenance. It's take a lot of money to buy those kind of machines, and the operation cost plus the maintenance cost as well. And in that era, the cost wise, it is very high, because you need to have the kind of mechanical engineers, high knowledgeable persons to replace those parts, right? Because and also it is not your main business. So let's say you are running an IT organization. So so your main aim is to grow up your IT business, not the like looking at the entire power solution. So it's not your main business, even though you have to pay attention for that power solution as well. But in nowadays, like after 80s, few companies like emerged, where they have the large number of these machines. So they collect large number of machines, producing the electricity, and they develop a mechanism to distribute that over wires to the business who needs that kind of systems. So this is a start of electricity grid. Like, so in that, after that era, you don't need to buy and maintain any machines anymore. You just have to connect their network and start consuming the power, right? So nowadays you don't have to spend a lot of money upfront, or you don't need to like you only need to pay for what you use only. So everyone has access, and it is easy to connect and get started, right? So nowadays, like in IT industry, we call the same solution. So we call this solution as a national grid. And sometimes we use the word called, so same concept we can apply for our cloud concept as well. But then again, you might heard a term called cloud technology, but again, we can say it's not a technology, it's a method of delivery of a business model. So this is how you can easily get an idea about what is cloud. And I'll tell you some other differences in between the older systems and new systems. So in old systems, you need to have a lot of money in upfront to buy a system, buy such kind of mechanisms or machines. And you have to maintain your own electric generation, engineers, part and cost. But a new methodology, everyone has access. Everyone is a part of that. And you only pay for what you're going to use. And it's very easy to connect. Right. All right. So in here, traditional IT infrastructure, right? So in traditional IT infrastructure, you can see in this graph, I hope you can see, right? You can see first one will be the time to market and the capital investment and the flexible, it's not very flexible to change, and the risk. You can see there are 4 columns, right? So it will start with the decision and the purchase order. Then you are planning for your hardware. So this is how you're going to implement your complete server structure, server room structure, right? Okay, so the best way to understand what cloud is to understand how we use it, like traditionally, and to see how we do things with cloud, right? Where I don't want like compare with the 10 years ago how we had it, but I just want to give you what were the problems we had in that kind of like situations. First one will be, it's like too much time to go live and get services up and running. So let's say you are an IT organization. Now you have a client. You need to like build a website and deploy that and provide the website access to outside world. So it takes more time, like because you don't have a server room, you have to fix the servers and purchase servers, maintain it and everything. And the next one will be you need time to spend a lot of capital investment upfront without even earning the revenue. Before you are earning the revenue, you have to spend a lot of money on that. And the rigid environment, that means it is very difficult to scale in or scale out, right? So once you purchase something, you cannot scale down. And again, if you need to scale up, it will be additional overhead as well. And finally, it can be risky. You don't know where your business will fail or success, right? So, right, for the alternatives of that, we can purchase provisioned environments. That means the servers, network, connectivity, DBs, apps. We can spin up those in minutes, right? And you don't need to pay anything upfront. That is again the quality or the feature of the cloud. And you can add or remove the capacity whenever you need. You can add anything, you can remove anything, scaling, scale up, anything can be done. And you don't need, if you don't need it, you can destroy it and wait. You don't want to pay for that anymore. All right, so that's how the traditional infrastructure looks like. Okay, so I have a small another slide for just give you some rough idea about like quick idea about the cloud. It's just nothing but you can see the picture and the diagrams, the text I have added. Before the cloud, every company had its own data center. Nowadays, you don't need the data center because you connect to the cloud and the qualities are there. Right. Right. Okay. Next, good one. Why cloud? Okay. If you Google this question, right, why do you need cloud? You will get like 50 different answers. But ultimately, it boils with three main things. Right. The first important thing, that means the most important one, is to achieve the agility of the business. So things are changing rapidly in both terms of like technology, business. How fast can you adapt to those changes will actually determine your growth and even survival as a business, right? So cloud will provide you the technology platform to do that. Okay, so let's say if you are a like software company and the way you develop your software need to be changed, the way you do the testing need to be changed, your project management methodologies need to be changed, and your delivery mechanisms need to be changed. Like, so there are a lot of things need to change around that to achieve your agility of the business, right? To achieve the agility of the business, you have to change a lot of things. So how we are going to change these things, right? So how we are like, for examples, how your finance department, let's say it's not like, so let's say you, let's say you spin up 100 of VMs in a couple of minutes in the cloud, but still the other department is taking more time to go through some kind of process, right? That means time to market is the main important thing. Time to market, that means it goes as under a agility as a business. That's the main important thing why we need cloud. And the second one will be the time and the cost. Again, the sub part of that, time and the cost. That means it also foster innovation. So innovation has two barriers. One is time, another one is cost. But the cloud solves both of these challenges. So when it comes to time, you can now do things in minutes and hours, like it's very quick. And if you want test an idea, you can do it very quickly. Right? You can do a test. And cost wise, you don't need to spend a lot of money to procure hardware and software to test your idea. You can just consume cloud services and you will be charged only for the usage. That will be the main advantage, main reason why we need cloud. And the second one will be the improving the customer experience. So in cloud, there are a lot of ways to achieve the high availability, fault tolerance in a cheaper way. So those are like kind of like qualities we are looking when we are moving to the cloud. So cloud is also about multiple venues. It does not matter where you are located. You can deploy your applications anywhere in the world. It doesn't matter where you are. Like in earlier cases, you have to stay with your on-premises data center and do the deployments and the things. But now, if it is in the cloud, it doesn't matter where you are. You can use a couple of softwares to access your data, your resources, and your utilities and applications through internet and access those things. And right. And what else? You need to like hire a data center, and it used to take a lot of time to do it and was very costly earlier. But now in cloud, it's just a matter of changing the region, and it's easy like that, right? So even like you can run your applications in different regions, but in earlier cases, you have to deploy another data center in that area and do that. But now it's very easy. And the third benefit, that means last benefit, the main three inside the third one will be the cost, right? So most of guys are thinking why the reason to moving the cloud is the cost. No, that is the third reason. But first one will be the agility of the business, time and the cost. Second one will be the improving the customer experience, how we can improve the customer experience. And third one will be the cost. Yeah, as I said, like most of people are think the reason that you need to move cloud is because of because it's cheap, but it's not true always, right? It's not true always. It can be even costly if you are just lift and shift the application. So if you are let's say you try to migrate your data center as it is into the cloud, we call that as a lift and shift to the cloud, it will be costly, right? Even your application has been designed to run on traditional infrastructure, and if you try to move it to the cloud, again, it might be costly rather than you running on your on-premises, right? So whether even it's cheaper, it's depending on what you do. And you also need to take it account the migration cost, re-architecting, re-platforming, right? Cost of your applications, how many traffic you are getting. Like there are several key areas you need to like think and you need to worry about when you're moving into the cloud, not the cost only. So as a business, you can now move to an open model. You don't need to spend a lot of money upfront to procure hardware and software, but you pay as you go only for the resources you are using. And this is very like attractive propositions to any business. And these are the reasons why we need cloud. Business agility, customer experience, and the cost. But any questions up to now? All right. Right. Cloud service models. Okay. So when it comes to the cloud, there are certain services and models working behind the scene. So making the cloud computing, so these the services and models are there for making the cloud computing feasible and accessible to the end user. So if we think about like end user perspective, there are two terms called models, service models, and deployments model, right? First, we'll talk about the service models. So in this screen, you can see three service models, right? So first one will be the on-premises environment, and then infrastructure as a service, then platform as a service, and third one will be the software as a service. So you can see in all these as a service columns, few are colored in let's say in orange color, and let's rest of others colored in green color. So these are like managed by provider in the sense cloud service provider. These are the things that you are managing. That means as an engineer or as a client, as a like data center owner, administrator, engineer, these are things that you are managing. And if it is on premises, you have to manage everything. Now you can see your underlying hardware is managed by your cloud service provider. So if you are moving from infrastructure as a service and platform as a service or software service, you can see the number of layers that you're managing will be reduced. And finally, you don't need to worry about anything. You can just plug and play that. You can just open that service and you can play with that and you can close it. So everything has been managed by your provider. So likewise, there are three different service models available: infrastructure as a service, platform as a service, and software as a service. So mainly in infrastructure as a service, and there are okay, I'll tell that later. Okay, in infrastructure as a service, that means the most basic level of the service. That means each of the service models make sure of underlying service model. That means the security management mechanism, security, the storage, compute, networking, operating systems, virtualization. So everything will be managed by your service provider. So infrastructure as a service provide access to fundamental resources such as like physical machines, virtual storage, and other things, etc. Right. So as an example, I can say for infrastructure as a service, Azure, AWS, Cloud, GCP, Oracle Cloud, Rackspace, HP. So those are the kind of like a infrastructure as a service examples. So AWS is one of infrastructure as a service example. And then you have the platform as a service. For example, I can say Google Docs. So if you're using the Google Docs, spreadsheets, Google Slides, so everything is coming as a platform as a service. The thing is like it provides the runtime environment for applications and deployments and deployment tools. So you can just go to the Google services and you can run this spreadsheet. So spreadsheet is already there. It is already installed. It's already managed on top of one of servers. We don't know where it hosted. We don't know where the application installed. Who installed the application? What is the version running? Can we update it? We don't know anything but finally you have the application running. The platform is there. You have just enter the data and use it. Right? You can run the whatever the queries. You can do the filtering, coloring, and anything. You can add the tables and all. Right? You can use this spreadsheet. And the final one will be the software service. For example, we can say Office 365, Dropbox, Gmail, right? Those are the examples. And in software service means it is a model that allows to use the software applications as a service to end user. So if you're thinking about the end user perspective, so let's say Gmail, you can just create the account and you can use it. You can send the mail, emails can be received, you can add the filters. See, you don't know where it installed, who installed that, what is the software, what are the APIs. No, you don't anything. You just create the account and you use it. Right? It's just like kind of a use. Right. Okay. Those are the like three main service models we have when it comes to cloud concept, cloud computing, and there are many more other service models as well, right? So there are sub service models. We can like call it as a whatever comes with XaaS. X means whatever the resource type, like infrastructure as service means IaaS, platform means PaaS. So likewise, there can be many. So as an example, we can say anything as a service. XaaS. So as an example, network as service, business as service, identity as service, database as service, strategy as service. There can be many more. All right. Okay. The second one will be the deployment models. So in the cloud, as I mentioned, there are two types. One is service model, another one is a deployment models. Okay, so let's talk about what is deployment models. Right. In deployment model, we have three deployments model. So it's basically meaning the how cloud is located, how cloud is located. That is the main purpose of the deployment models. Right. Cloud can have any of like these three models. There are actually, we have another model called hybrid model, but I haven't added here. Sorry, not the hybrid commute model. So here I have only mentioned the private cloud, public cloud, and the hybrid cloud. There's another thing called community cloud, right? I haven't added it, but I'll explain that as well, right? So public cloud. So yeah, let's talk about the private cloud first. Private cloud allows systems and your services to accessible within an organization. That means it's kind of like an inside the organization, right? So mainly we use these private clouds to keep our data secure. So we know no one from outside can access our cloud. So it's our private cloud. So there can be like advantages and disadvantages as well. So for advantages, we can say the data security, less risk, and we have the single tenant and compliance. We can add our own compliances and reliability. But again, as a drawbacks, not as a drawbacks, that pros and cons. Cons wise, we can say it's expensive because we need to establish our own cloud, right? So it can be kind of expensive, and the management of it. Instead of running our business, we have to take care of our private cloud as well. We have to manage it. We have to update it. If there are any patches, we have to install it. Right? We have to manage. Right. So then public cloud. Public cloud allows systems and services to be easily accessible through general public. That means through the global internet, www. So public cloud may be less secure because of its openness. So like as an example, email. So if we talk about the pros and cons, we can say the cost effective. It's very cost effective and on demand and unlimited scalability. It's on demand, right? Since it's a public cloud, we can use whenever we need, and when we don't know, we can stop it. And it's unlimited and scalability. It doesn't matter how many traffic comes, it will automatically scalable. And that is again the feature of public clouds. Zero maintenance. You don't need to worry about the maintenance and all, how it's going to be fixed and all, right? and it's continuous uptime. So if you are purchasing any kind of services from the cloud service provider, that provider is responsible to keep that service up and running for 24/7, not only 24/7, for an entire year, entire lifetime. And but the cons wise, low security, because we don't know where our data has been saved, because in the public cloud, the data centers can be in anywhere. We don't know where the compute servers are generated. We don't know where our data going to be saved, likewise. And it can be accessed over internet. Due to that, like, it can be like less secure. There can be some attacks coming from outside, since we don't know, because it's not our cloud, it's a public cloud. And there are multiple users are accessing multiple tenants as there, and the regulating complex. And the third one will be the hybrid cloud. That means it is a mix of private and public. So this can be some organizations are going to select the hybrid cloud as option. So the main reason will be it is portable. So you can move your resources from one cloud to another cloud. You are not depending on one cloud service provider. You are having like services or the resources in your own private cloud as well as a public cloud. So whenever you want, you can easily move your resources here and there, and you are not worrying about whether you have data protection, security safe, and it will be cost effective because you are using the both ways. So there will be less of risk as well. And flexibility and scalability and portability and the data transfer. So there are advantages and disadvantages, but then again, depending on your organization use case, your requirement, you can choose whether we are going with private cloud, public cloud, or the hybrid cloud. So the last one, the community cloud, I haven't mentioned here. It allows systems and services to accessible by a group of organizations. That's simple term of community cloud. You can refer it more if you need in internet as well. All right. So in the next slide, benefits. So what are the benefits? Okay. So what are the benefits of cloud computing? Cloud computing has numerous advantages. Not only the advantages, we have the disadvantages as well. So here I would like to mention it as a risk. Okay. So what are the benefits first? Okay. So benefits wise, that means one can access application as utilities over the internet. You can access your application over internet. That can be one advantage. And manipulate and configure applications online at any time. It's not like running, it's running. You can keep your services running entire 24/7. So you can access it online at any time. And also it does not require to install a specific piece of software to access or manipulate cloud applications. It's already there. Cloud computing offers online development deployment tools, your programming runtime environment through platform as a service model. So we talk about 3 service models, right? So platform as service model, everything is there. You doesn't need to worry about anything. You can just purchase it and run your application and produce the data. And your resources are available over network in a manner that provides platform independent access to any type of clients. And the next one will be, it will be offer on-demand self-service. You can go and select whatever you need. You can get a 2 CPU EC2 or 3 CPU EC2. You can select the storage unit. It's very easy. It's kind of like a self-service. You can manage your own. You can choose what you need. And your resources can be used without interaction with cloud service provider. So you don't want to communicate with your cloud service provider time in very present frequency. You can just select everything because everything has been provided for you. You are the person who manage everything. And whenever you need to increase some of the things, you have to go with the provider and raise the request and all. But most of times you can do it by your own. cloud computing is it's highly cost effective because it operates at high efficiencies with greater utilizations. Only thing is it need internet connection. And finally, it provides the load balancing as well. So if we talk about the high availability, it provides the highly available. So most of the services are highly available. So you don't need to worry about how many traffic comes, how the traffic going to be handled. So most of like managed services are managed by the service provider itself. So it's handled by its own. So what the disadvantages wise, we can like mainly talk about the risk. When it comes to risk, there are few parts available. So risk means like, although the cloud computing is a great innovation in the world of computing, there are like kind of like a downsides of the cloud computing as well. So for examples, let's say we can say security and privacy. So that will be the biggest concern about the cloud computing, since data management and infrastructure management in cloud provided by a third party, it's always risk to hand over like our sensitive information. So let's say the password, user information, bank information, clients, some sensitive information, right? So like so although the cloud computing vendors are ensure more secure password protected accounts, and any sign of like a breach would be result in loss of client and their businesses as well. And another risk will be the lock-in. That means it's difficult for the customers to switch from one cloud provider to another cloud service provider. It's a result of dependency on a particular cloud service provider. So that can be one thing. And isolation failure. That means the risk involves the failure, let's say failure of isolation mechanism. That means the separate storage, memory, routing between the different tenants. That can be kind of like a isolation failure. And there can be a management interface compromised, and insecure for the incomplete data deletion. So let's say you delete something, but it's not deleted actually in the destinations. So then again, your data can be breached. So there are like kind of like a risk as well, but you have to manage. You have to like decide what should be the best option if you're moving in the cloud. Any questions? Okay, so next will be the characteristics of the cloud computing. So when it comes to characteristics, you can see there are 1, 2, 3, 4, 5 characteristics available. So first one will be the on-demand self-service. That means the cloud computing allows the users to use web services and resources on demand. One can log into a website at any time and you use them. Right, that is the meaning of the on-demand self-service. Then the broadcast network access. That means since our cloud computing is completely web-based, it can be accessed from anywhere at any time. It can be broadly accessible. And measured service models, deployments model. Like we have already talked about the service model and deployments model. So that is going under the measured services. And rapid elasticity. That means it is very easy to like scale up and scale down, right? Scale up, scale down the resources at any time. So resources used by the customers or currently assigned to the customers are automatically monitored through resources to make it possible, right? You can monitor the resources usage. According to that, you can make the elasticity, like you can downsize resources, or you can like scale up and scale down resources whenever needed. And finally, resource pooling. That means it allows the multiple tenants to share pool of resources. So let's say one can share single physical instance of hardware, databases, and basic infrastructure. All right. So those are the main characteristics of cloud computing. Right. Cloud computing architecture. Right. So in cloud computing architecture, cloud computing architecture comprises of many cloud components. So you can see in this picture, there are several cloud components available. So each of them are loosely coupled. So by what do you mean by loosely coupled? Loosely coupled means the approach of interacting the components in a system or network that is those like we call those as elements. So elements are depending on each other, right? So those are interconnected components. That means also loosely coupled. So cloud computing architecture, we can broadly divide into two parts. One is front end, where you can see here front end and the back end. So front end is the completely client infrastructure plus internet, because those like two parts has been connected through internet. In the client infrastructure, the completely client's part, where the routing, networking, switching, and everything will be the hardware devices and how it connected through the internet. And the rest of the part, the backend, is completely a cloud service provider. So each of the ends are connected through network. Usually, it is via internet. So basically, front end refers to the client part of cloud company systems. It consists of like interfaces and applications that are required to access cloud computing platform. So example, let's say it's a browser, right? Your laptop. Backend refers to the cloud itself. It consists like all the resources. Like I don't want to again go and through, like let's say there are a lot of resources available in the cloud. Even if you take example the as AWS, there are a lot of services available. It comprises like data storage, virtual machines, security, services, deployment, servers, right? And one thing I want to highlight here, so it's a responsibility of the backend to provide built-in security mechanisms and traffic controls and protocols. So clients are using their components, their front end to access this backend. So they are storing their storage data, use the compute service network and everything here. So in backend, it's cloud service providers' responsibility to provide the built-in security mechanisms, traffic controls and protocols and everything. So these things need to be implemented there. All right, cloud computing infrastructure, right? Hope you can see the diagram as well. Yeah, okay, right. Okay, so mainly cloud computing infrastructure has these 1, 2, 3, 4, 5, 6 components, as you can see. Okay? There's no such a particular order, but below the hypervisor, you have the storage service and the compute, server service, that means compute, and the network service. And that on top of that, you are going to use the hypervisor service. We are going to manage the management software and deployment software. So I will briefly explain each of these layers and all. So mainly, if we talk about the hypervisor, which is like a kind of like a main part in the diagram. So it's like a low-level program actually that act as a virtual machine manager. It allows to share the single physical instance of cloud resources in between several tenants. So in the data center, so hypervisor going to manage, it's going to share the physical parts, physical components across the different tenants. And on top of that, you have the management software and the deployment software. Usually management software helps to maintain and configure the infrastructure, and the deployment software helps to deploy and integrate the applications to the cloud. And the bottom layer, you can see the network, server, and the storage. So basically, network is kind of like a key component of the cloud infrastructure. It's the one who is going to be mapped, like who need to be route, who need to be connect, and what are the things that need to be blocked and allow likewise. Like so, it basically it is also possible to deliver the network as a utility over the internet. So as an example, you can say the consumer can customize the network route and protocol. And the server helps to compute the resource sharing and offer other services as well. So there are a lot of services when it comes to compute services, right? And such as resource allocation, deallocation, monitoring resources, security auditing. There are a lot of. And finally, you have the storage, which use their distributed file systems for storage purposes. So basically, it has the backup feature and encryption mechanism. If one of your storage fails, it can like be extracted from another, which makes the cloud computing more reliable. So there are a lot of features. Like those are like advantages. So one can say the reason of why we are moving to the cloud as well. Right. Any questions? All right. Then infrastructural constraint of cloud computing. So these kind of some terms might not heard about, like you haven't heard these things earlier, but there are a lot of things when it comes to the cloud computing. And maybe these things like if you are like really worrying about how the cloud concepts, why this has been built, what are the purpose of that, in that kind of like thing, these points and these what you call terms are very much important. And these are the reasons why such services are implemented in such a ways, right? So here we are going to talk about the infrastructure constraints. So what do you mean by constraint? Constraint means the limitations. So the fundamental constraints that the cloud infrastructure should implement are, you can see in the diagram. So there are 4 parts in the diagram: transparency, scalability, and security, and intelligent monitoring, right? So let me start with the transparency. So basically the virtualization. So in the earlier slide we talk with the virtualization, right? Virtualization is the key to share the resource in the cloud environment in the transparency, but it is not possible to satisfy the demand with the single resource or a server, right? So whenever we use the virtualization, it's not possible to satisfy with a single resource or a single server. Therefore, there must be a transparency of resources, from which servers that resource is going to be allocated, how the load balancing happened, and where the application has been built up. So then we can scale them on demand, right? So whenever we request for a scale, like scale up and scale down, like it will try to access the not only the one resource but the shared resources to allocate and provide such a service. The scalability, scaling up an application, delivery solution, and is not easy as scaling up an application, right? So if you think about the application, scaling up an application is easy, but not like the application delivery. The reason is because it involves the configuration overhead and re-architecturing network. There are a lot of reasons as well in behind that. So the application delivery is need to be scaled, which will require the virtual infrastructure, such as the resource can be provided and re-provision easily. Finally, third one will be the intelligent monitoring. It is basically to achieve the transparency and scalability once again, right? So that application solution delivery will need to be the capable of intelligent monitoring as well. So it's like intelligent monitoring means like it's a dynamic method that employs like agentless approach with its monitoring. Final one will be the security. It's a data center in the cloud. That means should be secured architecture. That means your data should be, we need to know like how our data going to be secured, right? How our data going to be secured, and where our data going to be, whether it's those are going to be encrypted and all, whether those are backup and all, right? All right. So then we are moving to the cloud provider. So I have explained most of the cloud concepts. So seems like those are looks like same, but they have like kind of like a different meaning in depth. Right. So what are cloud providers? So mainly, since we are talking about the cloud providers, here I have mentioned all the public cloud providers, not the private and not the community, right? So all of these are the top 10 public cloud providers, right? AWS, Azure, GCP, Alibaba, Salesforce, Dell, IBM, DigitalOcean, Adobe, and Dropbox. And not everything provides, but all of these are cloud service providers. Services are different, like not every service is available in all the cloud providers, but they are provide the different services as well, right? Okay, cloud providers, the meaning of the cloud providers means they gives you the flexibility to build, manage, and deliver. Build, manage, and deliver small and large scale web applications and mobile applications, right? As an example, virtual server hosting, there can be many like storage service and load balancing, backup, encryption, key management. They provide you with diverse resources over the internet, such as like we can say big data analysis, IoT, compute, and there are many more services available to stream your business and agile and everything. Cloud resources are typically offered with a plug and play capabilities, allowing you to use only what you need and when you need it. Right. And there are 5 more things. Why do you need a cloud provider? Why do you need a cloud service provider? So basically, cloud computing offers numerous keys, like the numerics, like we can say numerics perks that are key to keeping up with the technology to cover the modern day applications. Main ones are like save money, speeding, scalability, security, and reliability. So saving money wise, we can say our cloud computing performs. Cloud computing provides you to save lots of money, including the upfront cost and cost of servers and hardware management, such as these. And speed-wise, we can say the majority of our cloud services are offered in self-service, pay-as-you-go, like they are speeding up very quickly. There are no like hardware is always there. Virtualization is always up and running. We can just need to like click the buttons and get up the services. Scalability, most of the cloud services providers are automatically scalable. They have the flexibility to access the resources right when they are needed, right? Rather than like having a single threshold, so there's specific parameters. Not about like we don't need to be worrying about the how it's going to be scaled and all, but everything provides as a scalability option is already there. Security wise, that means the most of cloud platforms offer an array of policies, technologies, control that protects your applications, data, infrastructure from threats, and all. And you can see the auditings, like who access what at what time. Likewise, you can get the reports and the logs are there, and you can implement the monitoring. And finally, reliable. That means how reliable our data is, how frequently we are going to the backups, how the key rotations are going to be happen. So we can back up your environment in the cloud and get on-demand access to your data to avoid any unnecessary downtimes. Right. So likewise, those are the reasons why we need a cloud provider. So let me explain about the couple of cloud providers that I have mentioned here. The AWS is Amazon Web Service, is a world-leading cloud vendor with over more than 200 of integrated features and services. There are many more, right? And also AWS offers free tiers that enables you to test your various services in free of charge without any commencements as well. Right, in AWS, they have the more than 77 plus availability zones and 24 geolocations, and they offer like more than 30% of the market share as well. The Azure is similar to the AWS, similar in the sense, I mean, like nowadays people are moving to the Azure as well, right? It's also provide on-demand compute services, designing for efficient building and the cloud. And most of the Microsoft application users, clients are moving to the Azure because it's already provide the Microsoft services there. Azure offers the 4 different kind of like cloud computing, like infrastructure as service, platform as service, software as service, and serverless as well. So you can visit AWS to amazon.aws.com, for Azure, azure.microsoft.com or portal.azure.com. And for Google platform, cloud.google.com. It's Google GCP is a assemblage of services that operate on the same infrastructure used to power Google Search, YouTube, and several other tech-based offerings. And then Alibaba, right? You can refer, you can like search in the Google and get the URLs. It will be the us.alibabacloud.com, as I can remember. So it's again the global leader of the cloud, which focus on security and artificial intelligence. And it's the second largest cloud provider around the world, right? And like powers almost like half of China's 4.9 million websites as per the like internet. Then Salesforce, again the cloud-based CRM tool, marketing automation, sales, customer services, like customer relationships management, like there are a lot of. And IBM, mainly for platform as service and infrastructure as service, provides the Hostics and cloud experiences. So similar to the AWS, Azure, so IBM also provide those services to help simplify many software development tasks. And DigitalOcean, digitalocean.com, designed to meet the lot of like mainly for developers that need to be deployed, scaling applications, run simultaneously on multiple computers. The cost-wise, some of the services are like cost-effective if you're using DigitalOcean. And the Dell also provide the virtualization, VMware softwares, and Dell technologies like multiple approach for a hybrid and multi-cloud dynamics, and the Adobe and the Dropbox, right? All right. All right. Okay. So in here, right. Okay. AWS global infrastructure. So in here, now we are moving to the AWS, since I have like already covered most of the cloud technologies and concepts of the cloud. So any questions up to now before we move into the AWS part? So AWS part, I'm not going to complete whole the AWS services or architecture or a concepts. No, I'm not going depth level. I'm just covering like surface level, just to give you idea. Okay, these are the services which has comes from that concepts that I already mentioned. Any questions? Okay, so first we'll talk about the AWS global infrastructure. Right, so when we're talking about the AWS global structure, it's a subsidiary of Amazon, launched in 2006. So it's a like $1 billion revenue company, more than like 25,000 or 30,000 employees, and there are a few different key persons, and they have the conference like annual conference, which is very popular, Dreamment. And yeah, so AWS has more than 1 million active customers located in all over like more than 250, I think nearly 250 or 240 countries across the globe, and encourage so AWS to expand the global infrastructure, constantly provide the client with lower latency and ensure higher throughput. So when it comes to the global infrastructure, there are two terms mainly we are talk with: regions and availability zone. Right. Okay. So if I tell you the difference between, let me explain you the region and the availability zone. So region will be cloud computing resources are hosted in, usually we know like it's a kind of a data center, but it's those are, we call those as regions. Amazon cloud computing, there's AWS resources are hosted in multiple locations in worldwide. So we call those locations as regions. So region is a physical location with a cluster of data center. It's not a single data center, it's a collection of data centers. Each AWS region is a separate geographical location, and each region has a multiple and isolated locations as availability zone. So inside a region, you have an availability zone as well. So most of times there are minimum 2 or 3. I think 2 is the minimum, yeah. Minimum 2 availability zones inside a single region. Most of the time it will be 3, but for a minimum in some regions, I can see only 2 availability zones available. Right, so regions are connected to the global network with like high power network cables, and connectivity in a region happen through a low latency and high bandwidth networks. If I talk about the availability zone, it's again the fully isolated infrastructure with one or more data centers. Again, availability zone is not a single data center. So small point will be like part will be the chunk will be the data center, and availability zone is again one or more data centers. Most of the time it can be 2, and region is consist with at least 2 availability zone. Now you can get some idea how the region and availability zone and data center has been mapping, right? And then there's another term called edge locations. You might heard about that. It's relatively small setup in different locations around the world. We use that is to reduce the latency, and like mainly used to cache our data and reduce the latency for end users. Not like we are not using edge locations to deploy resources like EC2 RDS and VPC. No, we are going to cache if we have some cache information, static information to put to reduce the latency. So then users doesn't need to send the request to the database to grab the information, or the storage services to grab the storage, the data. It can easily capture from the cache location. That means edge locations. Right. So there you can see snippet I have taken from the AWS website. So currently they have 26 regions, 84 availability zones, 70 local, 28, and you can see all the other information as well. So this has been taken from the official website recently. All right, then we are moving the compute service, right? So remember, so I have taken most of the services into the slides, but remember, not all the compute services are covered in these slides, because it's not practical to cover all the services in 2 or 1.5 hour sessions. It's kind of like a big theoretical part. Okay, so when it comes to compute services, so basically Amazon EC2 Elastic Cloud Computing, that's the reason the how the cloud EC2 has been written, right? Easy to Elastic Cloud Computing, you have 2 C's. Amazon EC2 provides a wide selection of instance types to optimize to fit different use cases. So let's say depending on your use case, you can select what are the instance types you need. So it's depending, let's say you have a service running on high performance computation power, then you can use the instance which is having the more compute power or more memory power, more IOPS power. If you're having a database, you need an instance which is having the more input output request can handle, you can go with the IO. Likewise, there are different models available depending on that, types available depending on that, you can select it. So usually the instance types comprise varying combinations of CPU, memory, storage, and networking capacity to give you a flexibility to choose the approximate mix resources for your applications running on that. And each of those instances include like one or more instance sizes, allowing you to scale your resources to with your requirements of your target workloads. So depending again on your requirement and your use cases, you have to choose what are the systems that you're going to use with that. Right. So after you have select, you chosen what type of instance that you're going to use with, you have to use you have to plan what is your purchasing option. So there are again types of purchasing options available. Sorry, the next slide. Purchasing options available. You can see in the slide on-demand instance, reserved instance, scheduled, spot, dedicated. So I'm not going like again reading and all about the diagrams and so on, because I'm not here to like going about covering the whole AWS lecture and all, right, theoretical part. But you can see here you are like free to select whatever you need. So there are a lot of purchasing options as well. So they provide the service as well as they provide the service. Again, they divide into different parts. Again, like, so you can classify, like structure your requirement. Then you can again divide into small parts, and again you can plan how you are going to plan with your infrastructure. Now, earlier I chose, okay, this much of hardware I need this computation power, I need this much of RAM and all. Now the purchasing model I can purchase, whether it's for short term or long term, whether I need my whole dedicated instance for me, or I need a dedicated host for me, or I can go with this spot instance. Right. So there are different use cases going for that. For an example, for spot instance, if you have like a short term, like a use case to run for like short time, then you can go for a spot instance where you can set the bidding price, and it will be very cost effective. And if you are running a server for like 1 month or 2 months of time, you can go with the on demand. But if you are running the same server for 3 years of that, you can go with the reserved instance where you are getting a good discount as well. Yes. So it's again depending on your use case and your requirement, you can choose whatever you need. And when you are using when you are try to start an instance, try to start a web server, here we call it as an instance. It has a kind of like a life cycle running on, right? So first you have to click on launch, then it will take some time to spin up your instance, not like the time taken from the virtualization like let's say you are running with the virtualization environment. It's not like that, but again it takes some time. So during that time you will get a pending state. Then once it will move into the running state, then you can access your instance. So instance can be accessible remotely, as well as there are 2 different options available through a management console. Also you can go and access your instance. So then you can reboot your instance when needed. You can stop your instance, and you can shut down your instance, and you can terminate your instance. So stopping means shut down. So you can reboot it. Reboot means it will be stop and start. Once you shut down, you can keep it in the stop state, or you can terminate it. Once you terminate it, the data in your the root device will be automatically get deleted. You won't get it back. All right. So when it comes to instances, when it comes to servers like online remote AWS servers instances, we need a particular image to spin up an instance. So let's say you are going to host a Windows machine, you need a particular operating system to use with that. So in Amazon, they provide AMI, Amazon Machine Image, which OS that provide the information to the launch instance. It support either Windows or Linux both, and can be launched multiple instances from a same AMI. So let's say you need to spin up 10 instances, you can use the same AWS provided instance. The advantage is that there are a couple of subscription has been added. So there are images has been added, and the image is more secured, right? you can copy that image. That image is available in all the regions. So you doesn't need to like download the image and update it and update it. No, it's already there. It's a secure drive, right? So there are again advantages, but you are free to use your own OS as well. So there are a lot of images available in compute service page. You can select whatever you need, but some of not under the free tier. That means you have to pay for that usage of that license or OSs. Right. Okay. Next one will be the addressing. So this comes under the compute service. The reason I add compute services here is because this can be going into network service as well. But basically, the way how you're going to select the IP addresses. So in this slide, you can see we have the two type of IP addresses. So these are in terms of IP version 4. Private IP address and public IP ranges. So you need to have some kind of idea about what is private IP ranges, what are the public IP ranges, and how can you select private IP, and how can you select the generated public IP of a machine, and how can you assign a static public IP to a machine. In AWS, we call it as a elastic IP, which is a public static IP. Right. So private IP usually account owners can decide which range to use inside a VPC. So VPC is virtual private cloud. We'll talk about that later. When we create a virtual private cloud, the account owners can decide what is the side range, classless environment routing, side range that going to be selected. Public IPs are usually associated with the AWS instances. Those are not fixed. That means the instances, those are aligned with that. And during the most of time, public IPs are associated with the instances, but those are not static. But there's another something called feature called elastic IP, which is you are getting a public IP and it is static. So usually public IPs are getting changed during the reboots, and you can own your customize. You can keep public IP in a statical way under elastic IPs as well. And there are a few limits for elastic IPs. Meaning maximum there can be 5, but you can increase it if needed. So I'm not going to like more depth into the AWS service and concepts because it might take some time as well. Right? Okay. Right. In next one, in next slide, we are going to talk about elastic IP. I think I have already covered that part. Then we'll move into the elastic load balancing part. Right. So in elastic load balancing, okay, that means so usually what happens when we are getting traffic, so our traffic distribute incoming the applications or network across multiple targets. So whenever we are getting high traffic, we need to balance it. Otherwise, our compute services might be get crashes. Even our database service might be get crashes. So there should be a mechanisms to balance the load. So there are a couple of techniques available, but basically the load balance, what it does is it spread the load across multiple instances, expose single point for applications, and provide high availability and TLS terminations, and separate public traffic from private traffic. That means it's perform the netting as well, network address translations, right? So so there are 3 type of load balancers available. Application load balancer, network load balancer, and the classic load balancers, where the classic is very older one, which is going to be depreciated, and the newer one ALB and the NLB. So again, those two have different characteristics. I'm not going to talk about those things, but basically load balancer do 2 things. One is network address translation. It will going to separate your public traffic from the private traffic, plus it will do the balancing part. It's routed distributed traffic across multiple targets. So targets is something when it comes to load balancing, you can assign instance into the different targets, and targets are the one who manage the traffic and distribute each thing. So there are different mechanisms available like round robin, active backup and all, but yeah, whatever you select, it will act like that way. Right. Any questions so far? Right. Okay. So next one will be the auto scaling. Right. So auto scaling means you are going to scale. So here you can see in the graph types of auto scaling I had it there. Reactive, predictive, scheduling, manual, and dynamic. So these are the ways of doing the auto scaling. Right. So okay, I got a question. Tenant can be a account, tenant can be a group. Tenant means, let's say you are having a subordinate account which is under the main account. So when it comes to AWS, we have something called organization, AWS organizations. Inside the organization, we can create different accounts into a main account. So in a main account, we call it as a main account, admin account, and under that you can create a different accounts aligning with that. So then those accounts we call it as a tenant account, where the tenants accounts all are managed and inherited by the policies and the rules assigned by the main accounts. That's how it has been distributed, and the most of the policies has been assigned to the main account will be inherited to a child accounts that been tenant accounts as well, right? In different, like there are different terms of tenant, but in AWS wise, that's a tenant. All right. So what else? Okay. So where I left. Okay. So when it comes to auto scaling, it can automatically handle the scaling policy, scaling mechanism without any manual intervention. You can set it up when it need to be scaled up. So let's say you can say, I need 5 instances at this time, but if I got traffic, if I get traffic more than this much, I need to increase it up to 10. So once that threshold reached, it will automatically do the scaling or build more instance and handle the load across those. That's how it automatically happens. And once ever it will freeze, you will get free and you are getting low number of traffic, it will destroy that unwanted or the idle instance as well. That's how it's going to eliminate and the minimize your cost. For that, they are used different kind of things like health checks, cloud dodge, and you can check it programmatically, or you can set the things in manually, right? You can, there are a lot of features there. So auto scaling provides under ASG. ASG means the auto scaling group. The service is free, but you need to pay for the underlying resources you are going to use. That, let's say you are saying you need 5 instances during the traffic, then you need to pay for that 5 instances during the uptime, not for the service. But we can read more information about that. Everything has been documented in the white papers or AWS documentation in very clear English. So there we can like read and get the idea how the costing going to be happen, because the costing is one of the most important thing when it comes to organizations, right? All right. So the second service will be the network service. Here I'm going to talk about the network service, the main component, since network part is kind of bit interesting for some people. Right. Mainly we'll talk about the virtual private cloud. So VPC in short term. VPC is a service that let you to launch AWS resources logically in an isolated virtual network. So network, that side range is going to be defined by yourself, or you use the default range as well. So VPC gives you full control over your virtual network environment, including your resource placement, connectivity, and security. So under VPC, there are some terms coming under IP addressing, subnetting, variable subnet mask, VLSN, basic routing, A gateway. What is gateway? A gateway means the network node. It's a kind of like a network node in telecommunication that connects two networks in different transition protocol to get connected. So uh, in AWS as well, we are having the different kind of gateways. Okay, if we talk about, like, you can see the diagram I have mentioned, you can see the AWS account, cloud computing, and then you have the region. So what is the region you are going to select where you are resources need to be implemented, then VPC which you are going to be created. So when you are creating a VPC, you need to decide what is your side range and what is your prefix. Inside that, you have the availability zone. Can you remember, in a region, we have more than minimum two availability zones. So in this case, you select two availability zones. Right? Why we select two availability zones? If something goes wrong with one availability zone, still your server or the website is up and running. Your application is running because you have another same application running the availability zone in the same region. Right. What is subnet? Subnet or subnetwork is a segment of piece of from the large network. The more specifically, subnets are like a logical partition of an IP network into the multiple or a small network segments. Right. Then another things like so basically, yeah. So you have to select some network range, subnet range for your VPCs, and whenever you create two or more VPCs, you need to make sure that the IP ranges, the side ranges are not overlapping each other. No, you can't create the same side range with the two different VPCs. Right. Next one will be the secret group. Okay, what is secret group, right? So this is again a good one. Like, hope you have heard about the firewall, right? If you are using a Linux instance or Windows instance, Windows Server or Linux Server, we are installing a firewall to secure our instance, the traffic coming from outside. So similar goes here. Here we call it as a secret group, but you don't need to install anything. It is a managed service. You have to just select it and click here and there and add what are the network ports, protocols, ports that you're going to allow and deny. Basically, it is already going to be denied. You need to allow the ports and the service which are coming from the outside. All right. So basically, the security group controls the traffic that is allowed to reach and leave the resources that is associated with. The characteristics of it, you can see in the diagram. The T2 means the instance I already spin up, and there you can see in blue color, I have enabled outgoing. We call this as an outbound, and this is inbound. So inbound, I have allowed port number 22 and another port number 22. You can see one is coming from the red color, another one is coming from the green color. So here, what I allowed is the whatever request coming from port 22 only for this IP. So then that request has been allowed, but this port is okay, but the IP is different, wrong. It's not matching with that. Due to that, I'm going to eliminate this traffic request. But for outside, it's allow everything. Then I can connect anything from outside, but only people who are coming from this IP will be allowed. So basically, controls traffic in and out for EC2 instance, act as a firewall, and those secret groups are attached to the elastic network interfaces, and it's locked to a region, and it evaluates the rules. So you can assign the rules. The rules are running in a particular order, so that there are different a lot of like theoretical terms behind that as well. But basically, it's a kind of like a firewall where you can allow deny network traffic for your instances. Right, internet gateway. Okay, so in earlier slide we talked about what are gateways. Okay, now we are talking about the internet gateways. Okay, so in this term, internet gateway simply is a horizontally scaled, redundant, and highly available. It need to be connected to the VPC. What it does is simply internet gateway enables you to connect to an EC2 instance in AWS using a local computer. That means you can connect to an EC2 instance hosted on top of AWS through internet gateway. So if you don't have the internet gateway, no one from outside would be able to connect to a EC2 instances on AWS. So you need to create internet gateway and need to create some kind of like routings. There are few routings need to be created, how the traffic will comes inside and go into that. But there are two purposes for the creation of the internet gateway. One is to provide the target for your VPC route tables for internet route traffic, and other one is to perform network address translation for instance that has been assigned for public IPv4 addresses. It do the net translation as well as it do the VPC, the routing path to VPC and the route tables. Right. So in this diagram, you can see in my internet gateway has been created there, because the reason is my public cloud public internet directly connect with the internet gateway. If I don't have the internet, I cannot connect with the EC2 instances. Right. Okay. So next one will be the NAT gateways. Okay. Again, this is a good one. Like, so NAT gateway. Why you need NAT gateways? So NAT gateway is basically in short term, NAT means the network address translation. You can use NAT gateways so that your instances in a private subnet. Okay, we have two subnet types. One is public subnet and private subnet. Most of times we are not hosting our services. We are not assigning our services in public subnet. The public subnets are publicly accessible and it is less secure. So we always keep our services in a private subnet. We have our databases, most of the time the EC2 instance, we are keeping in a private subnet. So then no one from the outside, even you as an administrator, cannot access the services inside the private subnet from outside, right? That is one thing. And the reason here why we need the NAT gateways are, whenever your instance, whenever you are the services hosted in private subnet need to get internet access, what you need to do, you have to go with the NAT gateways, right? You have to go with NAT gateways. Right. Okay. All right. NAT gateways replaces the source IP address of instance with the IP address of NAT gateway. For a public NAT gateway, this is elastic IP address of NAT gateway. For private NAT gateway, this is a private IP address of the NAT gateway. And there's another term called NAT instance, but I'm not going to talk about that. The good one and the best methodology will be the NAT gateway, not the NAT instances. Earlier we had something called NAT instance, but the NAT gateway is the most preferred one. Right. In next one, it will be the Bastion host. So what do you mean by Bastion host? Bastion host is a server whose purpose is to provide the access to private network from an external network such as the internet. That means, can you remember the early example I mentioned? We host all our private, we host our all resources and services in a private subnet. So then how from outside people access? Let's say to do a maintenance or to create a file or to update a package, to install some kind of service. How can people from outside going to be created? Is through the Bastion host. So Bastion host means another instances which we are hosting in a public subnet, which is can accessible from the outside. So then again, we have a security. We have a security risk because it's hosted on public, then anyone can access. But what we do is, if we are hosting a Bastion host, we are tightening our security there, right? We are allowing only for particular IP address from a particular port only. Then we need to make sure how we going to secure Bastion host. It's must to highly secure your Bastion host, otherwise your resources in a private subnets can be compromised, right? And there are another few terms like VPC peering. So if I talk about it, I haven't added those terms in technologies in the slides as well. The peering is something is like a connection in a network connection between two VPCs. So let's say you have two different resources in two different VPCs, like two different network ranges. How that each two get connected? How the EC2 in one VPC and EC2 in another VPC can SSH. You can't do that. For that, you have to create the VPC peering. So peering is enables you to route traffic in between two different VPCs. It can be in a same AWS network. It can be the different regions. It can be anything. Right. And then let's say your AWS services are accessing from the outside. So how the people are accessing AWS services from outside? One is through internet, but it is not a secure way. Then you have to implement VPN. Okay, AWS also provide something called AWS VPN client, which can be installed and you can be accessible AWS resources through a VPN. So it's a secure tunnel where your data can be will be encryption, and you can access the resources. Again, there are another several ways to access the AWS through internet. Some of are like accessing through some of like hardware network devices and cables and all, and some of are like remote features. So there are like few things called site-to-site VPN, which will connect with the on-premise data center to AWS over internet. So let's say you are going with the multi-cloud, kind of like a hybrid cloud where you have a on-prem and public cloud. Then you might need kind of like a site-to-site VPN, which will connect on-premises to AWS over internet. And there's another term called direct connect. Also, you can connect your resources in multiple VPCs from on-prem going through a private link. So there are a couple of like features available, and you might heard about something called transit gateways, where let's say you have some complex, when you have like complex network connectivities, like let's say you have like 10 to different 10 different VPCs need to connect each other. You can't go with the peering. Peering will be only connect two VPCs. If you have more than two VPCs need to be interconnected, you have to go with the transit gateways. Right. So likewise, there are different services available when it comes to network. So yeah. Any questions? Okay. So then okay. Right. So few of database models. I'm not going to like talk about like in very depth level, but when it comes to databases, we have two different terms. One is a relational database, and the other one is NoSQL databases. Where relational database is highly structured table organization data, and NoSQL means storage model is optimized for the data types. Right. So in the diagram, you can see the types of databases we have, the models. So some of our relational, some of our NoSQL. So depending on your requirement, we can see there are a lot more, right? There are a lot of services out there, but I'm not going to like talk about each and everything. But let me take one service here as a RDS. So RDS is one of relational database service, RDS. It has different engines. So if you go to the RDS, you can select what is your database engine you are going to search, either MariaDB, MySQL, SQL, what is the Postgres, what is the engine that you're going to be selecting. Then you have to select how many compute service you need. What is your compute service? What is your the base host resource? How it's going to be set up? What is the compute? What is the memory you need to select? So you have to decide how your underlying hardware need to be set up. You don't need to be set up, but you need to decide what is the capacity of your underlying RDS instance. All right. So it's a fully isolated database environment. It should be inside any of the VPs that you have created. Then the backups are there. It will be secured. You can make it highly available. Right. So when it comes to the databases, we are worrying about something called availability and the backup. Right. So we have two terms called read replica and multi-AZ. Some people might heard about these two terms, read replica and multi-AZ. So multi-AZ means simply it provides the availability of database instance within a single AWS region. So with multi-AZ, your data is synchronously replicated by a standby different availability. So that means it will automatically sync into a different database. So in an event of infrastructure failure, so let's say your main database got failed due to any kind of like issues, errors, or any downtimes, failovers, your request will be automatically fail over to the standby RDS instance to minimize disruption to application without any administrative intervention. Automatically, it will move to a that you are that automatically sync database without any manual intervention. So you can like perform your work like as usual. And the other term, read replica. Why we need read replicas is it will enable you to create one or more read copies of your database instance with the same region or in a different region to increase the scalability. So read replica is to scale the availability. That means scalability. So let's say you are getting more read requests. You are getting more database read requests, but you cannot handle with the single RDS instance. Then you can create many more read replicas where you can balance your load. You can distribute that read request to different read replicas. Then that you will get like your system will be get streamlined. Multi-AZ is for backup, like as a DR solution, disaster recovery solution, and our read replicas is for distributed traffic among the high traffic scenarios. Right. Okay. So next one will be DynamoDB. I have taken this as like, for example, for a NoSQL database service, which is available in the AWS. It is a fully managed NoSQL database from AWS. It's a key value document database, multi-region, multi-master architecture, distributed, unlimited scalability, backup, and everything will be there. Encryption. So it's a schemaless. This is AWS managed services, right? Right, so you can use this service and it has many more features, locking feature, encryption, a lot of features are there. All right, then I'm moving in the storage services. So there are mainly three different storage services available. You can see the file storage, block storage, and object storage. And some of services has been named EFS, EBS, EC2. Don't worry about the name of the service. I'm just like going with the theoretical concepts just to give you idea, okay? So we have learned about the cloud concepts. So concepts are there, that these services are built on top of the concepts, right? These services are working on top of those concepts to give you that the features, right? So storage is a service that allows to save the data on offsite storage systems managed by a third party and is accessible by a web-based APIs. So basically, object storage is based on key value addressing. It store data as a metadata, can be accessed through HTTP and APIs. And block storage offers raw storage to the clients, and those storage is organized as a set of blocks. Each block referred by a block ID, right? Those blocks can be organized as a file systems. So as an example, we can say iSCSI devices, direct attached PCIs. Those are the block storage devices. And finally, file storage. So file storage offers storage to the client in forms of files, just like files, maintaining stored file system. Thus, this storage is a from network attached storage. We call it as a NAS. Set of files accessed through the file IDs and used over shared network. So storage manage the underlying data on the disk as well, right? Okay, so most common scenarios we use NFS and Samba, network file storage and Samba. So examples of that file storage. You can see in the diagram, I had another diagram there. You can see how the difference between each storage types. You can see the fast performance wise, what is fast, and cost wise, you can see what is costly. So which is very fast will be very costly, and how it connected. This is connected through internet. This is connected through LAN wires. This is connected through power wires. That's why it's very fast. And the purpose of that, we use block storage for OSs to install and copy OS files. file storage just to like for like user purposes to store the files and all. And this is for the APIs and the use cases and scalability features. Like you can see the difference, and depending on that, you can select what is the storage type you needed. AWS simple storage service. This is one of like a storage service available there. Like S3 simple storage services, 3 S's. Due to that, we call it as a S3. So all the information are there. S3, we usually call it as a S3 bucket, because when we create a S3, it will create as a bucket. It's like a folder or directory in a traditional file system. It contains objects. So whenever we copy a file inside a S3, so S3 is a bucket. So whatever the object, whatever the files we stored, we call those as objects. Can hold any number of objects. The bucket, there is a like a way to rename the bucket. A limitation how many storage can be put into the bucket in a single run, single request. There are some kind of characteristics as well. Then different storage services. Yeah, hope you can see the screen as well. See, the S3 also has the different storage classes. Like so, S3 is a simple storage service, but it also has the different storage classes. Amazon S3 offers a range of storage classes that you can choose from based on the data access, resiliency, and the cost requirements of your workload. So depending on the data access, how frequently you are going to access, the resiliency, how long you need to keep your data, and the cost requirement. So what the cost effective way, some of things are costly effective, some of things can be read very quickly, some of things cannot read really quickly, you have to wait some more time, and some of things that you have put automatically get archived and you get more space. Like depending on the requirement, you can select what you need. Again, you have the table. So by looking at the table, you can see the availability, durability, and retrieval, and charge, latency, like life cycle, and charge. So everything has been listed in a table. So you have more features, right? So there are more options. So it's totally up to you to select the correct one. Yeah, right. Okay, so next one will be the file storage. So I have taken one example from another example from the storage service. One is S3, another one is EFS here. So it is like a fully cloud native and scalable network file system from AWS, which is hosted by AWS, provided by AWS. It's an NFS service. It supports NFS version 4, the latest version, I think. And it's compatible with the Linux-based OS. So if you have the Linux instances, whenever you need to create the NFS in between those two, you can just go and use the EFS service. No need to install the NFS package and all, right? You can just use the NFS service, then you can link those instances, then the both can be connected to NFS, network file storage, where you can put the data will be synced in other end as well. But you can see the couple of use cases as well: big data, media processing, home directories, content management, web serving. Right? There are many more. Right. Okay. So the next one. So we are moving to the end of slides. We are having one more slide only. AWS Storage Gateway. So what is Storage Gateway? So usually Storage Gateway is a hybrid cloud storage service that gives you on-premises access to virtually unlimited cloud storage. You can see again, there are 3 types of storage gateways: file gateway, volume gateway, and tape gateway. Again, the explanation is there. So again, you can select whatever the storage gateway types for your requirements, right? So I'm not going very depth about these terms and things, because it's like completely AWS service available. I just need to like give you idea what cloud computing is and how it's done all, right? So finally, we have something called security pillars. Some people might heard about this. So AWS has something called well architecture framework. So AWS well architecture framework means it has some kind of like key concepts and design principles and architectural best practices for designing and running workloads on top of cloud. So if you are a cloud architecture or a consultant who design, create, or provide the consultation for organization with these other like good service, this is how it's going to be happen and all, you have a good idea on AWS mail architecture framework. So okay, so let's say that like creating kind of like a software is like a constructing a building, right? So if your foundation is not solid, your walls and everything will be not like remain for a long time, right? So likewise, similar way goes to in AWS or the technical perspective as well. Like, so there were 5 pillars before, but nowadays there are 6. You can refer that in the official documentation as mentioned here. So first one will be the operation externals, which includes the ability to support and development and run workloads effectively to gain insight into the operation and continuously improve the supporting process and procedures to deliver the business value. And like the security pillar of it includes usually the ability to protect data, systems, and assets to improve your security. And then third one, performance wise, it says the ability of the workload to perform intent function correctly and constantly when it expected to, and also that includes the ability to operate and test the workloads through the total life cycle, the running life cycle. And next one, it's provide the ability to use the computing resources efficiently to meet the system requirements. And again, for the like to maintain the efficiency and demand on changes and technology evolves. Cost optimization pillar, that's basically the meaning of like it provides the ability to run the systems to deliver business at the lowest point. Yeah. And so the discipline wise, the discipline of sustainability address the long-term environmental, economic, and impact of your business and activities and all. Okay, so those are like kind of like a well architecture framework, the pillars where you can find more information of URL. I didn't like read about the official terms of the official meaning of each and everything. I just remember some things and I told you, but you can refer this link and read the complete official description of that. Then you might have more idea. I didn't read about those things. I just like give you some like explain from my words. Yeah, so that's is the full cover up for today, which I already planned, but let me give you one more slide of that. Right, if anyone looking for the certifications, so I prefer you to go through this site as well, or else you can access the below link where you have the get the more information of the certifications. It has the 4 levels: foundation, professional, associate, and specialty. And the cost wise, you can see the cost wise like this. And then security wise, I guess the exam price still under the 300. I don't think it's more than that, like, but it's not must to go through the structure. No need to, like, it's not a must to do the foundation and the professional, associate, and security. You can just skip the levels and do that. But I prefer, if you don't have any basic credit, you can go with the professional levels. This is not, I'm not like asking to or like advising to go with the only with the AWS. But if you are like AWS fan, you can go with, like, if not, like, there are another certification as well. Since I have like taken some of the AWS service here, I just thought to add this slide, because most of the time when I do some tech talks, people are asking about the certification, how I getting trained, how I get pro on this area, how I can learn the things. Okay? So this is the way of learning things. If you learn something, you can do the certification and gain it. But doing certification, it is not a must, but it is kind of like proof that you can do some things. Right. Yeah. Then, any questions? Right. Good. I think I have answered your question. What are the essentially required certifications and skills to get a well-paid job in cloud computing? Good. Right. So I think I have provided the answer for your question. I didn't see this earlier. Yeah. So to master anything, right? To master anything, there are only 4 things. One is read. Second, learn. Third, apply. 4, practice. Read, learn, apply, practice. So if you do this for again and again, like so you can master anything. So without read, you cannot learn. Without learn, you can't apply. Without apply, you cannot practice. Right? That is how it works. So try to refer official documentation all the times. You can go to I think the docs.amazon.com. Yeah, docs.amazon.com. Refer the official documentation always. If you need any further information, then you can refer any other training sites like Udemy or YouTube or official documentation. I prefer like first should be the official documentation, because there are no any bogus information. So every information is correct. Official documentation, white papers. Then you can go through their FAQs, frequently asked questions. If you still need some more information, then you can go for like third-party courses or YouTube videos and get the information. All right. So any further questions? All right. Okay, then. Thank you, everyone. Thank you very much for joining today. So I hope you gained at least some kind of idea on cloud computing and FIV on AWS and why we need cloud and what is cloud and what is the services and concepts, how it's going to be mapped with the AWS and all. So yeah, any questions? No, right? So, yeah. So feel free to if you are like technology enthusiast and DevOps learner or like a very newbie into the DevOps or the site reliable engineer or cloud, we have a good open source community there, DevOps Sri Lanka. You guys can join into that from the following links if you access, or you can Google it if needed. So I'm coming from that as well. Right. So thank you very much for joining. Over to Heshan if you need something.
Yamika, are you there?
Yes. Thank you very much, sir, for your wonderful explanation about that topic. Today's session is about cloud computing and AWS. Today our keynote speaker, he is working as a lead platform engineer, technical trainer, community lead DevOps Sri Lanka, and also working for the Red Hat architect and the certified trainer of the Red Hat. There is a power cut in our area, unfortunately. I think some of you have these power issues. However, we can't wait. Let's move on. Again and again, thank you very much, sir, for your wonderful explanation. Also, we have a small gift for Mr. Heshan Dharmasena. To hand over the digital token of appreciation, I would like to invite the president of IEEE student branch of University of Vocational Technology, Ratmalana, Mr. Heshan.
Thank you very much, sir. Accepting our invitation and give your accepting our invitation and give you a valuable time for us. Please accept our digital token of appreciation.
Thank you very much. Thank you very much. I'm happy to join with you guys. So let me know if you need any further support, any further sessions. So I'm happy to deliver that as well. Thank you very much.
Thank you. Sure.
Okay, thank you very much, both of you. So we are planning to take the group photo at the end of this session. Please stay with us. Now we are come up with the last moment of today to do the thank you speech. I would like to invite Secretary of IEEE Student Branch of University of Vocational Technology, Ms. Sanduni Pereira. Sanduni, over to you.
Amit, I think Sanduni also facing that power interrupt. Okay, I'll continue that. I think today's session we all have gained more knowledge regarding cloud computing and AWS. So I gratefully thank Mr. Heshan Dharmasena. Firstly, accept our invitation and conduct an interactive session today. Thank you again, sir. Then our student branch counselor and senior treasurer, Dean of Faculty of Engineering, Dr. Ravindra Kogelge, for helping to organize this session. Special thanks goes to Mr. Tenil Prabhat to contact Mr. Heshan Dharmasena, a valuable resource person for today's session. And thank you for all who participate in here. Thank you very much. Over to you. Yeah.
Okay. Thank you, Mr. Heshan. We are come to the end of this session. Let's take a group photo. Turn on those who can switch on your cameras, please. Cameras. Heshan, can you take the photo, please?
Okay, Amit. That's right.
Okay, thank you very much, all of you. Hope we will meet another brand new session very soon. Then everyone be careful. Good night to all of you. Stay safe. Good night.